before we try to create threads in Java, before we start with coding, I want everyone to be very clear about these terms. All of these approaches that have prefix multi, you need to be very clear on those terms. I'll give you some simple analogy to understand each of the approach and also appreciate the differences between each of these terms. You have multi-programming, tasking, processing, and threading. Excuse me. So only when you know the differences, you will be able to appreciate this multi-threaded programming feature supported by Java. So we'll discuss one approach at a time. What is multi-programming? Instead of taking processors and CPU, I'll take some day-to-day life analogy. Assume at a hotel, the hotelier has purchased a single oven. There is only one oven and he has appointed chefs. Say there are 4 chefs, C1, C2, C3 and C4. Since there is only one oven, at any given point of time, only one of them can be allotted. Either C1 can use this or C3 or either of C2 and C4. It cannot be shared, this oven. Correct. So in a multi-programming approach, the hotelier decides this oven should never be idle. He wants to make use of that most of the time. So that is his intention. So assume right now C1 is ready with all the ingredients, all the necessary mixtures. So he is using oven. So C1 is possessing this oven, and once he heats some ingredients, once he is done with oven, then there might be a need to procure some ingredients. Maybe he needs to cut some vegetables or get some more stuff from the store. So at that time he will relinquish this Okay, he is busy with some other task. So he doesn't want that. He has gone somewhere else. So at that point of time, this oven is free. And the hotelier decides it should be used by someone else. So he allots it to C2. And after some time, C2 doesn't want oven for some time. So he also goes to store or is busy in preparing some mixtures. So the main intention of multi-programming approach is keep the oven busy most of the time. It should not be idle. And in this case, there would be single oven. So in this analogy, oven should be thought of as CPU. And these are your processes. C1, C2, C3, C4. Okay. And before multi-programming practice was in place, in the olden days, even though the CPU was free, it was not given to any other process. So until and unless they were done with their task, CPU used to be idle whenever that particular process was busy with some other task. It could be waiting for IO process, or for any other reason it could have been suspended. So even under those circumstances, in non-multi-programming system, CPU would be idle. But with the advent of multi-programming feature, CPU was utilized most of the time. It was not idle. Okay, this is about multi-programming. Then we have multitasking. So in this case, again you have a single oven, and you have different chefs as in previous example. However, in this approach, in multitasking, the hotelier decides to allocate some time for each of them. He says, C1, chef C1, you use the oven for say 15 minutes. So once you heat your recipe or dish for 15 minutes, he thinks 15 minutes is the sufficient time window. So C1 will use this CPU for 15 minutes, and then C2 can use for another 15 minutes, and this goes on. This is time sharing approach, and this is also logical extension of multi programming, because the CPU is never idle. It will be used by one or the other chefs. Okay. Then we have multiprocessing. With time, the hotelier reaped benefits. He had better income, so he could afford more than one oven. Earlier there was only one, now he has multiple. So think of this analogy as multiple processors. So a single CPU with many cores. You have heard of dual core, quad core, correct? Now we also have 8 core CPU. So with the advent of improvement in technology, you have more number of cores for a CPU. So as you have multiple ovens in this analogy, the hotelier need not worry about allocating CPU to, he does not worry much about allocation of oven to individual chefs. So he can follow a simple approach. He'll give first oven to chef 1, another one to chef 2, third oven to chef 3, and C4 will use last oven. So this is multiprocessing approach. And remember, whenever you want to follow multiprocessing approach, you should have more than one processor. Having a single processor, you cannot say, I'll implement multiprocessing paradigm. Not possible. There should be a minimum of 2 processors if you want to implement multiprocessing approach. Okay. I believe these terms are clear. And most of the operating systems, whether you take Windows or Linux or Macintosh, most of these OS have some intrinsic mechanism to implement these features: multi-programming, multiprocessing, and multitasking. Now we will discuss multi-threading. And multi-threading is supported by very few languages, and Java is one among them. So Java has its own rich features as part of its libraries to support multi-threading concept. Are these 3 approaches clear? Please respond.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, that's good. Now we will see how multi-threading is different. Assume you again have 4 ovens, meaning 4 cores of a CPU, and 3 chefs have already completed their job, and you have only one chef now, C4, and this chef is aware of multiple processors. He knows that at the hotel there are multiple ovens and he wants to make best use of them. However, there is a limitation. At any point of time, he can access only one oven. So, he does not want these three to be idle. So, being a smart chef, he takes one decision. He hires some assistants. Under him, there are 3 cooks who can assist him in his recipe preparation. So these assistant cooks can be thought of as threads. And as you know, thread is very similar to process. The only difference being processes cannot share the resources. There are some resources which can be shared among threads but not among processes. Correct. This you are aware of. Now, these threads are also called as lightweight processes. So, by hiring 3 assistant cooks, this chef uses first oven. And since there are 3 ovens free and no one is using them, each of the assistant cook can use them. And since they can share the resources, whatever stuff has been brought by chef 4, it could be flour or vegetables or any mixture necessary to complete the recipe, it can be shared by all of them. So this is the idea of multi-threading approach. So in a multi-threading programming approach, you have one process and you have given some task to be performed by this program. It could be computation of different values, different statistical values. Say you have provided one array of numbers and this program or this chef has to determine different statistical values. It could be standard deviation, mean value, and frequency, and so on. So instead of expecting this main program, one process to compute everything on a single processor, what you can do is you can employ 3 threads and each of them will compute individual value using the computation power of 3 different processors. So at the same time, since multiple threads will be executing, throughput will be better. You get the results faster as a result of parallel computing instead of serial approach. And when we talk of thread in Java system, remember that garbage collector runs its own thread. When we were discussing about garbage collection system, one of you had asked, if I am executing a program, how does the control go to garbage collection? We had used gc command, remember? Gc function. It is possible because of multi-threaded approach. The garbage collector system, it runs its own separate thread. This thread is created by the Java runtime system. It is different from the threads created by you as part of coding. I hope the difference between these 4 terms is clear: multi-programming, processing, tasking, and threading. Now we will see one program, Java program, wherein in one of the programs the approach is serial in nature. In the same program, you will be invoking two different functions and they execute in serial order. And in another program, I have written multi-threaded program, meaning I have followed multi-threaded approach, and we will see how does that alter the output. In this file, I have two classes, train1 and train2. Each of them have a member function, reach destination. Within this method, I have a for loop. And within that, a message is being printed, how many kilometers a particular train object has covered. So the train1 object will be covering 1 kilometer at a time. I mean, it will display message whenever it covers 1 kilometer extra. So kilometer 1, 2, 3 till 10 kilometers. And then you have another class, train2, and it prints a message whenever it covers 2 kilometers at a time until it reaches 20 kilometers. Now coming to main function, I have created objects of train1 and train2, and then I am invoking member function, reach destination, on each of those objects. When we execute this command, the output should be, the first output will be from reach destination defined in train1 class. Correct? Because this program execution occurs in serial way. You cannot expect the CPU to switch between train1 function once and train2 another time. Until and unless this for loop is completed, the control will not come to definition of train2 method. Correct? Let me compile and see the output. This is output from train1 object. As I said, it is displaying message whenever it covers 1 kilometer. And this is the output from method of train2 class. So 1, 3. So it displays message regarding distance covered in increments of 2. So this program does not make use of multi-threaded approach. I have written one more program which makes use of thread concept, which is very similar to the non-thread program. There also I have two classes, train1 and train2, with similar method. Observe the difference in the output. In first case, until and unless the method defined in train1 class was completed, we could never see train2 messages. However, in this program where I have made use of thread concept, you can see the print messages mixed. First you get train2, then train1. Correct? There is interference. This is where thread plays an important role. If there are two processes, more than one core for a CPU, it makes use of both the cores so that no CPU core is idle. Now, how do we get to know whether your system has single core, dual core or quad core? And for every operating system, the commands will be different. Since we are using Linux system for our telnet server will use this command lscpu. This command gathers all the information related to your CPU. Pay attention to this line. So it says there are 4 CPUs, 4 cores for your CPU. Making use of multi-threaded approach is an intelligent decision in order to utilize these 4 cores better. You don't want any core to remain idle. See, you could be the only program running on your system. So even you are the only one using the system, you cannot make use of other 3 CPUs if you don't use multi-threaded approach. It is similar to that hotel example. 3 ovens are available, but due to the condition only one chef can use an oven at a time, the other 3 will be idle. Only when he hires some assistant cooks, those 3 can also be used. So in this program, I have made train classes as threads. Instead of objects of regular class, I have treated them as objects of thread class. As you know, every feature, every entity, every concept that you can think of in Java is a class. And when you have a class and you want to invoke some method on that, you need object. So when we say thread, there should be one class definition for that thread, and an instance of that thread will be thread object. This was true even for exception, correct? You defined exception classes. We had standard built-in classes, and you also learned to create your own user-defined exception class. And when you deal with them in program, there has to be objects of those type.